Welcome, dear students. Today's lecture is dedicated with the topic clipping, and it is related with the unit 5th. So, let's discuss what is clipping. So, first thing, you have already gone through the idea of a viewport. Okay, so in a viewport, we create any object. Okay, when we create any object that lies outside this viewport, so some of the part within related to this viewport lies outside the viewport, some part is lying inside the viewport. Okay, so when we view any object within a viewport, only this part will be visible. Okay, and this part will be omitted. So this is called basically the process of clipping. So the clipping, the visible part of the picture is identified. So once again I draw a window or a viewport related to which an image is generated. Okay, so this is the visible part within this viewport. And likewise, if I draw any other object like this, so this is the visible part within the viewport. So the visible portion of the So visible portion of the picture is identified through clipping. So we can say any procedure or algorithm or a method that identifies those portions of the picture that are either inside or outside of a specified region of space is referred to as clipping algorithm or simply clipping. So that is residing outside the visible region, and we have to consider the part of an object that is lying within the viewport. So clipping determines each element into the visible and invisible portion. Okay, so we are dividing the window into two parts basically, that is the area that is outside the window or a viewport, and the area that is lying within the viewport. Okay, so the object that is lying within the viewport, that will be considered as a visible portion, so that has to be selected. Okay, and whereas any portion that is lying outside the viewport, that will be considered as a invisible portion, that is your invisible portion. Okay, so if I draw once again and I draw a line here, so which part is visible? This part is visible because it is lying within the visible region, whereas this part will be invisible portion, so that is lying outside the visible region. So this will should be removed, discarded, or omitted. Okay, so these clipping algorithms can be applied in two ways. I have told you earlier about the window to viewport mapping. So we have two types of coordinate system. One is world coordinate, another one is viewport coordinate. So we do the mapping. Okay, so object can be clipped at two level. One is at the before mapping onto the viewport, the object can be clipped here only, and after that it is mapped to the screen coordinates, or first the object is mapped to the device coordinate and the clipping, and then after that clipping can take place. Okay, so in both way clipping can occur. that is clipping algorithms can be applied in world coordinates, so that only the contents of the window interior are mapped to the device coordinates, कि हम यहीं पर clipping कर दें और उसके बाद उसको मैप करें device coordinates पे. Alternatively क्या कर सकते हैं, complete वर्ल्ड कोऑर्डिनेट की पिक्चर को हम मैप कर दें डिवाइस कोऑर्डिनेट के ऊपर और उसके बाद उसकी क्लिपिंग करें. सो अगेंस्ट दैट व्यू पोर्ट, सो दैट इज द टू स्टेप प्रोसीजर. एनी वन अल्टरनेटिवली कैन बी used. Okay, so that is the clipping. Let's see with the help of certain figures. Okay, so I have distributed the clipping into number of cases. Okay, so in the first case visible lines are shown and this is the window, or we can call it as a viewport. Okay, so this is visible lines that is lying within the visible region or within the window. Okay, now next is case 2, that is the invisible lines. Okay, the lines that are lying outside the visible region, so that is residing outside the viewport. So this is another case that can exist related to the clipping. So all the lines that are lying within the visible region, that is the one case. So these are called visible lines, and the case 2 is the invisible lines, where the lines are lying outside the visible region. Okay, some other cases may also exist where the clipping will take place. So there is no clipping is required because the complete line is lying within the visible region. Here no clipping is required basically across the edges, reason being because all the lines are lying outside the visible region. Whereas in some other cases you can see the clipping will take place. For example, case third, clipped lines. So a line is drawn, okay, a point. So this part will be clipped, okay, across the intersection of its edge. So we will be able to calculate the points p1 in certain manner. We will see ahead of it how this intersection across the edges are calculated. So simply are the point of, so p1 is the point of intersection across this edge, p2 is the point of intersection for this line across this edge. So we will calculate it, and we can see this part is the visible line and this part is the visible line in this case. So this will be accepted and this will be discarded. Okay, this will be removed or this will not be considered. So when we will have a look onto the viewport, only this part will be viewable of the lines. Okay, so another case has been shown, that is a mixed thing. All things are mixed together. That is a line that is completely residing outside the viewport, a line that is completely lying within the visible region, and this is the line that requires the clipping across an edge, that is across an intersection of this edge. So the clipping will be required, and when the clipping is done, so this part that is lying within the invisible region, it will be discarded, whereas this will be accepted. So in this manner we do the clipping basically. Okay, so let's move ahead. So this lecture is particularly concerned with the basics of clipping. Okay, so let's once again go with this. So when we talk about clipping, so here with the help of certain figures it is shown that how clipping is taking place. For example, this now with the help of the Cartesian coordinate values, this can be enumerated, that is x min in x direction, x max, y min, and y max. So simply, so we are ranging this clipping area, that we are ranging our viewport from x min, y min to x max and y max. Okay, so this is the region within which our viewport will lie. Okay, so here the figure is shown. So this is before clipping, the lines are drawn, a figure is drawn. Then after clipping across the intersection of its edge, this one is removed, this one is removed, this one is removed, this part is removed, this part is removed, and this part is removed, and it is totally accepted. So this is before clipping, and this is after clipping. Okay, so here also a line is shown with the line points x0 and y0. It is given across this edge, the line is cut down and this point is calculated. Let's say this is p1 and this is after clipping this, let's say this is p2. Okay, so this line will be shown, or this line will be accepted and rest part will be discarded after clipping. Okay, so in certain way we will be able to calculate these points, and we have to find this which line has to be clipped and which line has to be discarded completely or not acceptable, so that we will see. So here the window against which object is clipped is called a clip window. Okay, so this is called the clip window. So this is called a clip window, basically the window against which the object is clipped. Okay, so this is called the clip window. Now clipping can be applied through a hardware, means this can be implemented through the hardware as well as software. So hardware can also be designed for the clipping, that will allow you to do the clipping on the device coordinates. Okay, and also the software programming can also be used to do the clipping. So in some hardware, in some computers, hardware devices automatically do the work of clipping, whereas in some systems where the hardware is not available for clipping, we can also have a program or an algorithm that can be implemented in a software manner to clip the objects. Okay, so this clipping can be applied through hardware as well as through software. Moving ahead with it, so clipping can be tricky. That is, we can clip a line, we can clip a polygon, we can clip a point. So different types of clipping can be done. So in this figure, it is shown, the triangle is shown, and this is the, simply this is the window, or you can call it as a viewport. Okay, within that the object will be shown. So this rest of the part will be deleted or discarded. So here it is shown the rest of the part is discarded and deleted. So this line, you are left with this point, you are left with this point, particularly this line. If this would have been a, and this triangle has been drawn with the help of a line, if it would have been drawn with the help of a line, okay, or clipped with using the line clipping algorithm. So this line will be there after clipping, this line will be there after clipping, and this line will be there after clipping. So here you can see there were two edges, three vertices, A, B, and C, whereas after clipping the number of vertices has been increased. So in vertices were 3 and outwards vertices are 6. So the vertices may also get increased after clipping. Okay, so this is one of the case that you can see when clipping is done. So what the number of vertices may also increase. So one more thing can happen, that if you have a one consolidated object that can split up into two different objects. For example, this is complete one object. Okay, this is complete one object, whereas after clipping the two different objects have, you have received after clipping two different objects. So it was completely, in was only one polygon, whereas out was out output as output you have got two polygons. So number of objects may also increase in case of when you are performing clipping. So we will see how it is done. Okay, so let's talk about some the applications of clipping that is very common, that you can easily understand. So it will extract part we desire. When we do clipping, the part of the object can be extracted out, or it can be taken out, or it can be used for identifying the visible and invisible area in, this is not a bullet, it is a continuous statement. So for identifying the visible and invisible area in 2D and 3D objects, so we can easily find the object is drawn a 2D or some simply a cube is drawn. Okay, so some part if you want to operate or want to identify, then it can be done with the help of a clipping. And for drawing operations, we can use the clipping when we want some hidden part to be shown or some hidden part has to be clipped and some part has to be clipped likewise. And for also deleting, copying or moving part of an object from one position to another position. So in these cases the application and the clipping can be used. So these are the few applications of the clipping. So going ahead with it, so when we do a clipping, then clipping can be done in five of the categories. One is point clipping. Okay, point can be clipped individually. Then a consolidated a line clipping can also take place. So we will go through the line clipping algorithms. We have different kinds of line clipping algorithms. That is, for example, one is Cohen, Sutherland line clipping algorithm. Okay, you have midpoint subdivision, midpoint midpoint subdivision line clipping algorithm. Then you have the Liang Barsky Liang Barsky line clipping algorithm. Okay, so ahead of it I'll cover these two algorithms that is related with your course, that is Cohen Sutherland line clipping algorithm and midpoint subdivision line clipping algorithm. So this will not be covered as it is not within your course. Okay, so this is another method, another algorithm through which the line clipping can take place. Okay, then we have the polygon clipping algorithm in which we will go through the Sutherland, Hodgman polygon clipping algorithm. Okay, so we can also clip the curve and we can also clip the text, but this is not in your course, so we will not go through this topic, how the clipping is done in such cases when the curve is given to you and how when the text is given to you. So simply, so we will follow our course in which we will cover up the point clipping algorithm. We can clip the line, how the line is clipped using the Cohen Sutherland line clipping algorithm or the midpoint subdivision line clipping algorithm, but we will not go through the Liang Basky because it is not in your course. Then we will follow the polygon clipping, how the polygon clipping is done. Okay, because polygon clipping is different from the line clipping. Reason being because the polygon is a closed object. Okay, when we clip a polygon we require a closed object so that it can be filled with shaded patterns or solid colors basically. So if it will not be a closed object, then the filling cannot take place. So how we receive the closed object after clipping, that is done only by the Sutherland Hodgman polygon clipping algorithm. So we will follow the procedure how we clip the polygon to have a closed object. Okay, so this a polygon, if we have a polygon, okay, and if I'm applying the line clipping algorithm on it, means line by line I am taking. Okay, So this will not lead to the closed object. It will not give you the closed object after clipping. Okay, so individual lines will be clipped. Individual lines will be clipped. So in such cases, for example, let me demonstrate you, so it will be easy to understand. For example, this is a window and you have a triangle over here, so it is a polygon. If I apply a line if I will apply a line clipping algorithm, so what you will get after clipping, you will get this. Okay, you will get this. The rest of the part will be removed. So these three things will be removed, you will get this. Okay, so to be a close object, you must have this edge too within your clipping. If you will not have this, you cannot fill it up. Okay, so but line clipping algorithm will not allow you to get this line across the edge. So this can only be achieved using polygon clipping algorithm. That is why we have a separate polygon clipping algorithm, because line clipping algorithm does not give you the closed object after clipping. Okay, so these are the few types of clipping criteria. So we will go through point clipping, line clipping, and polygon clipping. Whereas in line clipping, we will not follow the Navier-Stokes clipping algorithm. Okay, so let's have a discussion on point clipping algorithm. Okay, what is point clipping algorithm? So basically, point clipping algorithm allows you to identify that whether a point is lying, whether a point whether a point is lying within the visible region or outside the visible region. So simply we are finding it out or identifying whether this point is within the visible region or outside the visible region. Okay, so every point will be given with the x and y value. Okay, every point is provided with a unique address, that is x comma y value. Okay, and simply by checking out the x and y value with the inequalities of x min, x max, y min, y max, you can easily find whether this point is within the visible region or outside the visible region. So if it is less than x min, so it is means the point is lying here somewhere. If it is x1 is less than x min, then x1 is lying somewhere here. Okay, so if I'm talking about these 2 points, x naught, y naught, and x1, y1. Okay, so simply we can check the inequalities of, we can check that this point x, this point having a value x and y, whether this x is lying below to the minimum value of x, so it is outside simply. Okay, and likewise x1 is lying below to the x1, then it is outside. If x naught is greater than x1, so it is lying outside. If x1 is greater than x1, it is lying outside. Likewise y naught is less than y min, then it is outside. Okay, and if it is y1 is less than y min, then it is outside. Okay, and if it is y naught is greater than y min, means it is above this, so this is outside. And likewise y1 is out above y max, then it is outside. So in this manner we can check whether the point is within the visible region or outside the visible region. To check the inequality whether the point is within the visible region, you can check, means the point must lie within the value of x min and x max, or it must be equal to or on the boundary, you can say. Okay, so any value of x that is within the range of x min and x max will be considered, that is the point is within the visible region. Likewise for the y, If it is lying within the range of x min and x y max, then this y point will be considered that it is lying within the visible region. Okay, so it should be trivially accepted. By looking at this inequality, we can check whether this point is should be accepted, or by looking at this inequality we can check whether this point should be rejected. Okay, so simply by checking these inequalities we can say a point is lying within the visible region or a point is lying outside the visible region. If it is lying outside the visible region, it should be rejected. If a point is lying within the visible region, it should be accepted. Accepted means it should be displayed. Okay, it should not be displayed. Okay, it should be discarded. Okay, so simply this is all about your point clipping algorithm, and we can check with these inequalities that whether the trivial rejection can take place or trivial acceptance can take place by looking these inequalities. Okay, so with the help of point clipping algorithm we can also clip a line. Okay, so line is a combination of points. So if a line is given AB, we can go with by checking each point on a line, or each point of the line can be checked with these inequalities and can be find out which point on a line is within the visible region and which point of the line is outside the visible region. So simply whatever the number of points that are lying outside the visible region should be discarded. Okay, and whatever the number of points that are lying within the visible region should be accepted. But we cannot go with the line in the same manner as we go with the point, because it will be a complex algorithm to check out, a complex procedure to check out each and every point of a line. Okay, so for that purpose we have another algorithm that is called Cohen, that is called your Cohen Sutherland line clipping algorithm. Okay, so to clip a line, basically we will not follow the point clipping method. Okay, so this is the basic method through which you can check whether a point is in the visible region or outside the visible region. Whereas when we talk about a complete line, it is a complete line. So if we apply a point clipping method on this, so it will be a complex and it will take too much time to clip a line. Okay, so we must have certain another method to clip a line in one go across the edges. Okay, so that method will be solved by the Cohen Sutherland line clipping algorithm. So I'll cover up this Cohen Sutherland line clipping algorithm in the next lecture. I hope you are able to understand the basics of your clipping. So simply clipping is done across any window or viewport. So it simply identifies the visible portion and the invisible portion. The portion that is lying within the window or the viewport, that will be considered as a visible portion. The portion that is lying outside the visible region or a viewport or a window, that will be considered as a invisible portion. So whatever amount of the object that is lying outside the visible portion, it should be discarded, and the portion that is lying within the visible region should be accepted. So after clipping you will get this. So I hope you are able to understand the what is clipping and what is point clipping, what are the applications of the point clipping. Okay, so I'll start with the Cohen Southern line clipping in the next lecture. Thank you all.